Good morning, students. Welcome to Commando Group of Schools online classes. So, in previous class we learned what is a polynomial and the basic concepts of the polynomial, and also we learned how to find the zeros of the polynomial, and then for linear polynomial, quadratic polynomial, and cubic polynomial also. Now, today we are going to discuss and we are going to learn how to find the zeros of the polynomial by using graph. So by using graph also we can find the zeros of linear polynomial, quadratic polynomial, and also the cubic polynomial. So today's topic is graphical representation of zeros of a polynomial. So how to find the zeros of the polynomial by using graphs. So first we have to take one example. So to find the zeros of the linear polynomial, we will learn how to find the zeros of the linear polynomial. Now, if I take the example as find the zeros of p of x is equal to 2x minus 4. Now, I have taken one linear polynomial because here the degree is 1, so it is a linear polynomial. Now, we are going to learn how to find the zeros by using graph for this polynomial. So, to draw the graph, first of all we have to know x and y coordinates. But here only x value is there. So here x value also we don't know, only we are having the variable x. So first we have to find x and y values. So for that, first we have to equate the polynomial to some y. So let y is equal to 2x minus 4. Now here we don't know x and y. If we know the x and y values, then we can draw the graph. So to get x and y coordinates, so we have to take the assumed values for x. We can take any value for x. So here I am taking x values as -2, -1, 0, 1, 2, and 3. So in place of x, I am substituting some negative values, positive values, 0. So we can take any values. So here we are taking negative, positive, and 0 values. So if I substitute in place of x as some -2, then we will get y value. So what will get y value if you substitute -2? -2 into 2 is -4. -4 minus 4 you get -8. Similarly, if you substitute x is equal to -1, -1 into 2, -2. -2 minus 4 you will get -6. Similarly, if you substitute in place of x as 0, then you will get -4. So if you substitute x is equal to 1, 2 into 1 is 2, 2 minus 4, again we will get negative value -2. Similarly, if I take x is equal to 2 in this, then 2 into 2, 4 minus 4, we will get 0. Similarly, if I substitute x is equal to 3, so x is equal to 3 means 3 2s are 6, 6 minus 4 will get 2. So first we have to take x and y values. So if you substitute x values, then we will get y values. So first we have to take table like this. So after forming the table, now first we have to write the coordinates. So how we have to write the coordinates? First x value we have to write, then after that y value. So first we have to write the coordinates. Therefore, the coordinates are, what will get the coordinates? X is equal to -2, y value is -8. So -2 comma -8. So that is first coordinate. Similarly, -1 comma -6. Then after that 0 comma -4. Then 1 comma -2. After that 2 comma 0. Then 3 comma 2. Now we got the coordinates. So after getting the coordinates, we have to plot these points on the graph. So first we have to take the graph, and we know that the horizontal line we call it as x-axis and the vertical line is y-axis. So I am taking, this is the x-axis and the vertical line, let it be y-axis. So x-axis and y-axis, the intersection of x-axis and y-axis, which is nothing but origin. So we have to take here origin O, it is denoted with O. So here we have to take 0. Now from 0 to this side, right side, it is positive x-axis, and left side is negative x-axis, let it be x dash. Similarly, 0 to here upwards it is positive y-axis, so this one is negative y-axis, let it be y dash. Y dash. Now take the real numbers on the x-axis and y-axis. So here we are taking 1, 2, 3, 4, 5, 6, 7. 7. Similarly, on left side we have to take negative values. That will be -1, -2, -3, -4, -5. And similarly, on y-axis, so here it is positive values 1, 2, 3, 4, 5, 6, 7, 8. On this side, we have to take negative values 1, 2, 3, 4, 5, 6, 7, 8. So like that, first we have to take the real numbers on the x-axis and y-axis. Then after that, we have to observe the coordinates. Here, the first coordinate is -2 and -8. So this -2 is nothing but we have to take on x-axis and -8, that is y-axis. So the intersection of this x-axis and y-axis, we have to take this point. So -2, that is, here it is -2 and -8 is nothing but we get here. So the intersection of these two. So this point is the coordinate -2 comma -8. -2 comma -8. Then after that again -1 comma -6. So -1 and -6. So we'll get, so the intersection of these two. So here we'll get. And this is -1 comma -6. Then after that 0 comma -4. 0 and -4. So here we'll get, and this is 0 comma -4. After that 1 comma -2. So 1 positive value. So 1 comma -2. -2 means we'll get here. This is 1 comma -2. Similarly 2 comma 0. 2 comma 0. After that 3 comma 2. 3 and 2. So these are the points you have to plot on the graph. So if you join all these points, then we'll get one straight line. Straight line, and this line is nothing but the polynomial y is equal to 2x minus 4. 2x minus 4. So if you observe this one, if you draw the graph of the linear polynomial, we are getting the straight line. So what we can conclude, the graph of a linear polynomial, the graph of a linear polynomial is the straight line. Straight line. Okay, up to here, okay. Then how to find the zeros of this polynomial? So we have to observe that here the straight line of the graph, where it cuts the x-axis. The graph where it cuts the x-axis, that we have to observe. So here the graph cuts the x-axis at 2, 0. The graph cuts the x-axis. Cuts the x-axis at 2, 0. So first we have to take the point where the graph cuts the x-axis. Then after that, here 2, 0, this is the point. Now in this, we have to take the x coordinate as the 0 of this polynomial. X coordinate, whatever it may be. For example, if it cuts the x-axis at -5, 0, then we have to take the zeros of the polynomial is -5. So here it cuts the x-axis at 2, 0. So we have to take the x coordinate only. X coordinate only we have to take as a 0 of the polynomial. So for this linear polynomial, the 0 of the polynomial is 0 of p of x is 2. So like that, you can find the zeros of the polynomial of a linear polynomial by using graph. So now take another example, so which is a quadratic polynomial. So for that polynomial, so we have to learn, we are going to learn how to find the zeros of that quadratic polynomial. So take example. So let it be, find the zeros of the quadratic polynomial p of x is equal to x square minus 5x plus 6. X square minus 5x plus 6. Now it is a quadratic polynomial because the degree of this polynomial is 2. So it is a quadratic polynomial. And now we have to find how to find the zeros of this polynomial by using graphs. So here also, first we have to take the polynomial as some y. So let y is equal to x square minus 5x plus 6. So after that, we have to know x and y coordinates. So to get x and y coordinates, we have to give different values to x, then we will get y value. So here also same. So we have to take x and y values. So how will we get y values? By substituting x values. So here, substitute in place of x some real numbers. So here I am taking the values as, let it be -3, -2, -1, 0, 1, 2 and 3. So here I am taking some positive values, negative values and 0. So we can take any values. So similarly, if we substitute x values, we will get y values. So how will we get that? Before that, we can write here, to get y values, first we have to write how many terms are there. Each term we have to write here. So x values we have substituted. So after that, here 3 terms are there. We have to write 3 terms separately. So this is x square value. Then after that, this one is minus 5x value. Then third term is 6. And this is constant. Now, if you add these 3 values after substituting this x value, then finally we will get y value. So if you add these 3, then we have to get y. We have to get y values. So we have to get y values. So first substitute in place of x as -3. So -3 whole square. So the power is even number. So minus it becomes positive. So -3 whole square you get 9. Similarly, in place of x, if you substitute -2. -2 whole square is, again you will get positive value 4. Similarly, if you substitute x is equal to -1, -1 whole square. -1 whole square is nothing but -1 into -1. Again you will get, it is a positive value 1. So if you substitute x is equal to 0, here you will get 0. Then after that, if you substitute x is equal to 1, so 1 square is 1. Then if you substitute x is equal to 2, 2 square you will get 4. Similarly, 3 square you will get 9. So this is the x square term. Then after that, we have to take minus 5x. So minus 5 into x. X is nothing but these values. So in place of x, we have to substitute -3. So minus 5 into -3. Minus into minus plus, 5 3s are 15. 5 3s are 15. Similarly, again, if you substitute x is equal to -2. So minus into minus plus, 5 2s are 10. Then after that, if you substitute x is equal to -1, minus into minus plus, 5 into 1 is 5. So then after that, 0. If you substitute 0, then this term will become 0. Then after that, if you substitute 1, minus 5 into 1, minus 5. Then if you substitute x is equal to 2, minus 5 into 2, you will get minus 10. Then after that, if you substitute x is equal to 3, minus 15 you will get. Then after that, this is the constant. Here, we should no need to substitute x value because we don't have any x value here. It is a constant. So directly we have to write same that 6 only for all the values. 6, 6, 6. So we have to write the constant for all the terms. Then after that, if we add these 3, x square minus 5x and 6, then we will get y value. So to get y values, we have to add all these 3 terms. So 9 plus 15, 15 plus 9, 24, 24 plus 6. 24 plus 6 is 30. 30. Then after that again, 6 plus 4 plus 10, 14. 14 plus 6, 20. Then after that again, 1 plus 5, 6. 6 plus 6, 12 you get. Then after that, 0. So 6 only you get. Then 1 plus 6 is 7. 7 minus 5, 2. So here if you observe, then 6 plus 4, 10. 10 minus 10, 0. Similarly, 9 plus 6, 15. 15 minus 15 is 0. 0. So, like that, if you substitute x values, we are getting y values. So, and from this, we have to first we have to write the coordinates of these points. So, how will we get the coordinates? X values and y values we have to write as points. Now, the coordinates are so what are the coordinates? Coordinates are minus 3 comma 30. Minus 3 comma 30. So that is 1 point. And then minus 2 comma 20. Minus 2 comma 20. Then after that minus 1 comma 12. Minus 1 comma 12. And then 0 comma 6. 0, comma 6. Then after that 1, comma 2. Then 2, comma 0. After that 3, comma 0. 3, comma 0. Now we got the coordinates. So if you substitute these coordinates, or if you plot these coordinates, if you plot these coordinates on the graph, then on the graph paper, then we'll get the graph. So now take x-axis and y-axis. Let it be this as x-axis and this one as y-axis. This is negative y-axis and this one is positive y-axis. Here it is positive x-axis and this one is negative x-axis. And the intersection of x-axis and y-axis, and this is origin, and let it go. Now we have to see the coordinates. On x, this is x coordinates. All is minus 3, minus 2, minus 1, 0, 1, 2, 3. All their x coordinates. All their smaller values only. So we can take 1, 2, 3, 4, 5. So like that we can take. So negative means we can take negative values minus 1, minus 2, minus 3, minus 4, and this is minus 5. On y-axis if you observe, and if you observe the y coordinates here, minus 30, 20, 12 and 6, so somewhat bigger values. So what you have to do means, we have to take on y-axis, we have to take the scale as 1 centimeter is equal to, let it be 5 units. Otherwise you can take 2 units. So if I take 5, 10, 15, 20, 25, 30, 35, 40. So I am taking on y-axis 1 centimeter is equal to 5 units. So here minus 5, minus 10, minus 15, minus 20, minus 25, minus 30, minus 35, 40 and minus 45. So on x-axis we are taking 1 centimeter is equal to 1 unit, and similarly on y-axis we are taking 1 centimeter is equal to 5 units. Now if you plot these points, then what do you get? Minus 3, 30. On x-axis we have to take minus 3 and 30. 30 is on y-axis. So the intersection of these two, so we get that is the minus 3, 30. Similarly the second one, minus 2, 20. Minus 2 is on x-axis and 20. So the intersection of these two, so here we get the point minus 2, 20. Then after that again minus 1, 12. Minus 1 and 12. 12 is nothing but, so more than 2. So approximately I am taking here. So its value is minus 1, 12. Then after that, then 0, 6. 0 and 6. So I am taking approximately here. So its value is 0, 6. 0, 6. Then again 1, 2. On x-axis 1 and y-axis 2. So let it be this point as 1, 2. So I have taken below the 5. So it is 1, 2. 1, 2. Similarly, next one is 2, 0. 2, 0 you get here on x-axis, and 3, 0. 3 and 0 means you get the point as in there. If we join all these points, then we will get a curve. We will get a curve like this. If we join all the points, we will get a graph which is a curve. And if we, here it is, if we substitute different values, then again this line will be extended like this. So approximately you will get so like this. And if you observe this graph is like a U shape. The graph is like a U shape. So this U shape we call it as parabola. So what we can conclude is, so if you draw the graph of the quadratic polynomial, and we will get a curve which is in U shape, and that U shape we call it as the parabola. You get the parabola. Now, how to find the zeros by using this graph? So similarly, just now we learned how to find the zeros of a linear polynomial. How we find it? So the straight line where it cuts the x-axis, that point is the zero of that polynomial. Similarly, here we have to observe this U shape or this parabola where it cuts the x-axis. So here, this parabola cuts the x-axis at two distinct points. So what are the points? The graph cuts the x-axis. The graph cuts the x-axis at 2, 0 and 3, 0. Here, this parabola cuts the x-axis at two distinct points. One is 2, 0, another one is 3, 0. So from this, how to find the zeros? We have to take the x coordinates. So in this x coordinate is 2. Here in this point the x coordinate is 2. So the zeros of the given quadratic polynomial p of x are. So you get two zeros. What are the zeros? 2 and 3. 2 and 3. So like that, we can find the zeros of the quadratic polynomial by using graph. So just you have to remember that for the graph of a straight line, the graph of a linear polynomial is a straight line, and also if you draw the graph of a quadratic polynomial, we will get a U-shaped curve. That curve we call it as a parabola. And how to find the zeros of the polynomial means, so the graph where it cuts the x-axis, that x coordinates we have to take as the zeros of that polynomial.